Bismillahirrahmanirrahim. Okay, so today we are going to start the new chapter, that is electrostatic, which is the basic of which is similar to the chapter static electricity, which we studied in grade 10. Okay, uh, so we will try to go through the basics as fast as possible so that we get to learn the new things. Okay, the first topic that we have is charge. Now, let us go through the books. About 600 years before the birth of Christ, Greek philosopher Thales first observed that if amber or Solomon's stone is rubbed with silk, it can attract small pieces of paper. We know that what happens whenever we are rubbing one object against another, some electron transfer will take place, right? Between the two objects, one will have higher electron affinity, and that object will be taking electron from the other object. So as one object is losing electron, it will become positively charged, and the other object is gaining electron, it will become negatively charged. So in normal condition, when the body is not charged, it is neutral. That means equal number of electron and proton are present in the object. So that time it does not have any power to attract. Okay, but when it is charged, then it gains then it gains a capability to exert a certain amount of force on some other object. Okay, it might be attraction force, or it might be repulsion force. Okay, so the name electricity is originated from electron, the Greek name of amber. Okay, keep few pieces of paper on the table. Now comb your hair with a plastic comb and hold it near pieces. You already know this. So the comb will attract the pieces of paper. Eta amra jani. Let us go through the electrification, the definition. Okay. As a result of rubbing, everybody acquires more or less the power of attracting other bodies. This phenomenon is called electrification. Okay. The electrified bodies, as a result of rubbing, the bodies which acquire the power of attracting other bodies are called electrified bodies. I hope these definitions need not to be explained in details. You understand, right? Anybody wants me to discuss about these definitions? No. Okay. Now, electricity, the nature and effect of static or moving charge is called electricity. Static electricity means the nature and effect of a static charge is called static electricity. Current electricity is
স্ট্যাটিক চার্জ মানে কি?
when
চার্জ মুভ করে না?
static means the charge is not moving. That means whenever we rub two things, okay, some electron transfer will occur, and one of them will become positively charged, another of them will become negatively charged. So what is happening? The charge has been stored here. The charge is not moving. As long as you don't connect them with a conductor, the charge will not flow back. So this is static electricity, when the charge is not moving. But if you make them connect with a conductor, or if you make them come into contact with each other, what will happen? They will exchange the electron again and become neutral again, right? So when you make them connect with the conductor, then the charge is moving, so that is current electricity. Okay, because current is flowing. Understood? Two types of electricity we already
স্যার
have. That is static electricity when the charge is not moving, and current electricity when the charge is moving. Acha. So we know all substances are constituted with very tiny particles. These are called atoms. Yes, true. Again, atoms of every substance are constituted with electron, proton, and neutron. Now, electron revolves around the nucleus, that is out of the nucleus. And in the nucleus, two types of element are there, that is proton and neutron. Now, proton is positive, electron is negative, and neutron is neutral. Okay. The fundamental and characteristic property of these particles, electron, proton, neutron, etc., that constitute matter is called charge. Achha. The property charge is actually a property, right? like electron, the charge of it is considered to be negative and proton is considered positive. আচ্ছা, এরপরের লাইনগুলো আসলে তোমরা জানো, the amount of charge of proton is equal to the amount of charge of an electron. In an atom, the number of proton and electron is equal in normal condition. Okay, proton and electron, they balance each other, so as a result it remains neutral and it doesn't show any electric property. The number of proton and electron in different substance is different. In hydrogen atom, there is one proton and one electron, but no neutron. Yes. In the helium nucleus, there are two proton and two neutron and two electron revolve outside the nucleus. You actually know the atomic number, right? বাংলা এটাকে আমরা পারমাণবিক সংখ্যা বলি. So that actually gives the number of electron in a particular element. Now that is equal to the number of proton also. Okay. In helium nucleus there are two protons. Then as nucleus is very heavy, it cannot dissociate from the atom. On the other hand, electrons are light, so they can move easily. Yes. Now one question might arise that if there are three particles, electron, proton and neutron, why it is that only electron can move? Actually electrons are free to move. Actually if you see it, if you take a look at the structure of the atom, you will see that at the center there is nucleus, and what is happening, like the planet, the electron is revolving around it. Okay, so if something can be done, we can take one or two electron from here. Okay, but it is very hard to displace the center. Okay, what is revolving around the center, that is hard to displace, but that is easy to displace, but it is hard to displace the center. Okay. Acha. And the atoms where number of electron is more, some electrons can isolate themselves with the free electron. Yes, these are some electrons are called free electrons, which are free to move. In an atom, so long the number of electron and proton are same, it remains non-electric and electrically neutral. This is what I was just saying. Okay, when it is not charged, not positively charged, not negatively charged, in normal condition, it is neutral. Okay, and it doesn't show any electric property. But if the number are not same in an atom, that means the number of proton and number of electron are not same, not balancing, then what will happen? Either it will be positively charged or it will be negatively charged, depending on which one is more. Okay, if you see that number of proton is higher than the number of electron, then it is positively charged, and if it is the opposite, then it will be negatively charged. But the number are not same in an atom, then what will happen? The atom becomes electrified and hence the substance becomes electrified. By applying external force, heat or by chemical process, free electrons can be taken out from atom. Yes, there are several processes. By applying heat, rubbing, several processes are there to get the electron out of the atom. As proton is heavy and it is bounded in the nucleus by nuclear force, it cannot be isolated easily. If in an atom number of electron is decreased, the number of protons becomes greater. This state is called positively charged. And then they have explained how to become negatively charged, which you know already, so I'm skipping it. Okay. So in normal state, the number of electron and proton in the atom of a substance are same, but every atom has an affinity to get electron more than necessary. Yes, atomer একটা electron প্রতি weakness আছে. That weakness is called affinity. Okay, and the atom likes to get, okay, the electron. বাংলা এটাকে বলে ইলেকট্রন প্রিয়তা, মানে ইলেকট্রন পছন্দ করে, ঠিক আছে? Thus, when two substances come into contact with each other, the substance whose electron affinity is more, it collects free electron from the other substance. This is also we know. Then actually they have said about the things that we already know. That is, they talked about the ebonite is rubbed with a flannel, then a glass rod with an silk. So this example we already know, so let us not waste any more time reading this. If you want, you can go through this paragraph on your own. Okay, and in table actually they have given a list So what is the list about? Hmm. Now there is a serial. If you see 1, 2, 3, 4, like that, it continues up to 18. Now if the object that is at number 1 position, it will become positively charged if it is rubbed with any object that is below it. That is from 2 to 18. Any object you take from it and rub it with far that is at number 1 position, so far will become positively charged. So any object you take from here, like at number 5, I have mica. So if I rub it with any object that is listed between 6 to 18, then mica will be positively charged. Then oppositely, if I rub mica with any of the object that is listed between 1 to 4, like far, wood, flannel, then what will happen? The mica will become negatively charged. Okay, so this is the serial who will become positively charged. Okay. Now next we have quantization of charge. Let us go through it. Um, from many experiments, it is now known to us that the charge of a body must be an integral multiple of a minimum magnitude. Right. Um, it's not like you can say that 2.5 electron has moved from one body to other, right? It cannot be like that. Okay, the charge of electron is this minimum magnitude. The charge of one electron, this one also we know that is minus 1.6 into 10 to the power minus 19 coulomb. This is the charge of an electron. And what is the charge of a proton? In case of proton, this minus will just become plus. Okay, same amount of charge, just plus. Acha. If E is the charge of an electron, then the total charge of the body would be Q equal to Ne, right? Q equal to Ne. So for one electron, we know the charge to be minus 1.6 into 10 to the power 19. So 10 to the minus 19 coulomb. Then if I have 5 electrons, then my charge will be 5 into 1.6 into 10 to the power minus 19. Okay. So this is what they have represented by E, and N represents the number of electron present. So if I multiply, then I will get the total charge present within the object. Okay, clear?
Yes, sir.
Okay. Now, the magnitude of charge of a body cannot be continuous. It would be discrete. That is, it would be the integral multiple of the charge of electron. This is called quantization of charge. Okay, this is the quantization of charge. Therefore, it is possible to get an object whose charge is 15e or minus 7e, but it is not possible to get an object whose charge is 4.65e. This is what we were just talking about, right? The number of electron. It is just like the number of students. Okay, if I ask you in a particular class how many students are there, you will always give me a discrete value, not indiscrete value. If you remember about this discrete and indiscrete topic, we talked about this one when we were studying the statistics in general in grade 10, okay, 9, 10. So discrete value is the value which cannot have any means decimal or fraction value. Like you can never say the number of a student of a particular class is 24.5. Now, what does it mean by 24.5? 24 full students are there and another student have only the half part. So it is not possible, right? So this is discrete. Then we have conservation of charge. Now the amount of charge in the universe always remains same. Conservation means whenever we are talking about conservation, we know that the total amount is fixed. It is not changing. Okay, the total amount is changing. Yeah, sorry, the total amount remains same. Now the object might exchange charge between each other, but the total amount will be remaining same. Let me give you an example. I explain this with this analogy, that if two person are there, okay, let us say one of them is having 80 taka, okay, and the other one of them are having 20 taka. So as the result, total together, how much they are having? They are having 100 taka, right? Now let us say the person who was having 80 taka gave 20 taka to this person. Okay, so this person will have now 80 minus 20 is equal to 60 taka, and this one will have 20 plus 20 equal to 40 taka. So 60 plus 40 total is still 100, right? So even though they are exchanging between themselves, the total always remains same. Doesn't matter how much they exchange with each other, their personal money, amount of money might change, but the total will always remain same. So this is what we mean by conservation of the money. Okay, or here we are saying conservation of charge. This is same as conservation of energy. Okay, energy might be exchanged from one form to another, but the total amount of energy in this universe is always same. Acha. Now that is, charge cannot be created or destroyed by means of any physical process. Charge may be transferred to one body from another body, like giving money or exchanging money. But no new charge is created nor destroyed during the process. From the frictional experiment of glass rod and silk cloth, it is observed that the amount of negative charge goes to silk cloth from the glass rod is the same amount of negative decreases in the glass, right? যে অ্যামাউন্টের টাকা ও ওকে দিবে, মানে ওর থেকে যতটুকু কমে যাবে টাকা, ও ততটুকু বেড়ে যাবে. So as a result, they actually balance each other. It is the same like the, if I rub them against each other, then what will happen? One will give up the electron. The number of electron given up by one body is equal to the number of electron received by another body. So as a result, they balance each other. Acha. Then we have this thing called point charge. Okay, anything left in the previous paragraph? No, I guess it is okay. So point charge, charges stay at the outer surface of a charged object, right? If you have a circular body, let me draw it. If we have a circular body, then what will happen? If I make it charged, then the charges, extra charges will stay on the surface, not around the center. It will stay around the surface. Okay. So the charges stay at the outer surface of a charged object. If the charged body is very small, like a point, then the charge of the body is called a point charge. Okay, that means the body, if I reduce the size of it and it becomes a dot, a point. Okay, if it becomes like that, then it is called a point charge. Okay. If the size of the objects are very small in comparison with distance between them, then they are considered as point charges. The calculation regarding charge becomes easier if the charge of an object is considered as point charge. Okay, so this is actually a concept we use to simplify our calculation. Okay, the thing is, it doesn't have a significant effect. Okay, it simplifies our charges, but it does not make it is not like that. For considering this situation, um, a great difference in calculation occurs. Okay, Acha. It just simplifies our calculation. Acha. The next topic we have is Coulomb's law. Now Coulomb's law we already know, right? Do I need to explain it? If you remember, the Coulomb law is kind of similar to the gravitational law, okay, of Newton. Now Coulomb law is given by Coulomb, which is similar to the gravitational law given by Newton. Yeah, if you remember, in gravitational law there was two body. Now in Coulomb law there will be two charged object. Okay, so between two body in the universe, between any two body, some force will be acting. This is what Newton said. Coulomb is saying between two charged bodies, some force will be acting. Now this gravitation law says that how we can calculate the amount of force, and Coulomb law says how we can calculate the force between two charged bodies. Okay, so the force was proportional to the product of the mass of the bodies in case of gravitational law, and in case of Coulomb's law, what it is going to be? The force will be proportional to the product of the charges. Let us say the charges of the bodies are Q1 and Q2. So F will be proportional to Q1, Q2. Okay? And if you remember, in case of gravitation, it was inversely proportional. The force was inversely proportional to the square of the distance between them. Similarly, in case of Coulomb also, okay, the force is inversely proportional to the square of the distance between them. That means if as it is inversely proportional, if you increase the distance, the force will decrease. This is true, right? Okay. Okay, so this is true for human also. Like two friends, when they are together, the bonding, the force between them, the attraction force between them is very strong. But as they get separated, like one friend moved to other town, so some distance has been created, so the force between them starts to get faded. Okay. Achha, so if I write the law on the board, I will not be writing the statement because you know it already. I will just write the expression so that you can use it later for numerical problems. So what I said, F is proportional to Q1, Q2, the amount of charges. That means you increase the amount of charge, you increase the force between them. And F is inversely proportional to the distance between them. Q1, Q2, the distance between them is R. Okay, so the force that will be acting. Okay, now if I combine these two, I will get F is proportional to Q1, Q2 divided by R squared. Now, if you remember, whenever we have a proportional sign and we want to replace it by an equal sign, we need to introduce a constant, right? So if I want to give equal sign here, I must introduce a constant, that is C. And this was known as Coulomb's constant, right? Now here actually we will get to know more about this Coulomb's constant, okay? But do you have time? I don't think. I have another class at 9:50. It is 9:51 already. So I would like to request you to go through about this Coulomb's law. I will tell you the page number, okay? Kindly go through those page numbers: 67, 68, 69, 70, and 71. That is up to electric field. Actually, electric field also something you know. It is the area in which if I place another object, another charge body, so the original charge body will be able to exert some force. Okay, you know this electric field, so go through this also so that we don't spend enough time behind this. Then electric intensity, this is also you know. So this one also you should be going through. I will be starting the discussion from charge density or surface charge density. That is in page number 74. So from 67 page to 74 page, kindly go through all the topic and bring up your doubt. Okay, mark it with pencil and ask me doubt in the next class. Okay, I don't think I need to discuss in details about this. One thing I will discuss, that is actually permittivity of medium. Inshallah, we will discuss about this in the next class. Okay. So kindly join the next class. We will see you tomorrow, inshallah. Some chats are there. Sir, আমার মাইকে ডিস্টার্ব তাই রেসপন্স করতে পারবো না। আচ্ছা 48 আমার এখানে কি 48 মারিয়াম কি 48 তোমার এখানে নাহরিন স্যার নাম আবার ফিজিক্স ক্লাস ও ইয়া ফিজিক্স ক্লাস কয়টা থেকে শুরু ফিজিক্স ক্লাস
স্যার এরা থিঙ্ক করছে 9:40 থেকে স্টার্ট
না না 9:40 না তো 9:50 থেকে আচ্ছা যাই হোক ওকে লেট আস এন্ড দ্য ক্লাস থ্যাংক ইউ ফর জয়নিং